In the first lesson of this training system, the trainee learns basic terminology used in press shops, such as blanks, slugs, piece parts, forming, and so on, and learns the basic components and operation of mechanical power presses. In the following segment from Lesson 1, the trainee is learning how the drive system in a mechanical power press works, and how the press cycles when triggered by the operator.
However, the way in which most mechanical power presses are driven and operated is similar. The electric motor drives the flywheel. The flywheel spins freely. The spinning flywheel stores the energy for the stamping operation. There is a clutch and a brake to start and stop the crankshaft. After loading a blank into the dies, the operator pushes two palm buttons, or on some presses, a foot control. This causes the clutch to engage the crankshaft to the flywheel. The energy stored in the flywheel turns the crankshaft. The turning crankshaft moves the ram up and down with the pitman. As the press returns to the top of a stroke, the clutch disengages and the brake is applied to stop the crankshaft. One complete rotation of the crankshaft will stamp out one or more piece parts. A rotation of the crankshaft is called a stroke. The ram always starts its stroke at the top of the crown or frame. This position is called top dead center or stroke up. At the bottom of the stroke, the punch stamps the blank against the die. The bottom of the stroke is called bottom dead center or stroke down. After the ram returns to stroke up, the blank is removed by the operator or the blank is automatically ejected into a part chute or powered.
In Lesson 2, the trainee will learn how to safely start up the press and begin manual operation. He or she will learn how to load blanks and stamp them using either two-hand controls or foot controls. In the following segment from Lesson 2, the trainee is being shown many types of press safety devices and how they operate.
Two-hand controls require both hands of the operator to be used to cycle the press. Palm buttons must be pushed at about the same time and held until the hazardous portion of the stroke is completed. If you release the buttons too early, the press will stop. These are the pullback cables on a manually fed press. The purpose of the pullback cables is to assure that your hands are out of the work area during the downstroke of the ram. The pullbacks must allow the operator to reach far enough to put a blank in the die. Yet they must prevent the operator's hands from being in the work area during the downstroke. At the beginning of each work shift, whenever a new die is set up or whenever an operator is changed, your supervisor must check the pullback device for proper adjustment. This is a light curtain on a continuously operated press. A row of light beams shine between the two sides of the light curtain. Both hands must be away from the die area before the press cycle will start. The press will stop cycling when an object such as the operator's hand breaks the light beams. Light curtains can be used to protect an operator only with part revolution clutch presses. Barrier guards may be used to provide operator safety. The purpose of barrier guards is to prevent entry of hands or fingers into the die area. Guards may consist of fixed panels or have adjustable sections like this one. Guards which are interlocked with the press control may have a movable section to allow access to the die area. Movable barrier devices prevent entry of hands or fingers into the die area only during hazardous portions of the press stroke. Movable barrier devices are sometimes called gates. Restraint or holdout devices prevent the operator from reaching into the die area at all times. They must be properly adjusted for each operator. These are safety tongs. They may be located on the press or may be part of your personal safety equipment. Make sure you know exactly how to use the safety devices and equipment provided by your...
Lesson 3 shows the trainee the main components of die assemblies and the major types of press operations. The trainee will also learn to identify different types of piece part features and how these features are produced by the punch and die. This information is critical in developing good troubleshooting skills and for communicating problems to the die setter. Lesson 4 instructs the trainee on identifying and correcting, if possible, a wide range of quality problems. In the following segment from Lesson 4, the trainee is being shown the steps in the shearing process and how to identify piece part problems which can occur during shearing.
Cut band should be about 1/3 the thickness of the blank or less. The remaining rough portion is called the break or break-off. It will usually be tapered. This is a graphic illustration of what happens during the shearing operation. There are 3 stages. The first stage is called plastic deformation. During this stage, the punch presses down through its stroke and begins to bend or shape the material. This produces the radius on the edge. Notice that the punch forms the radius on the top of the scrap, while the die forms the radius on the bottom of the blank. The second stage of the shearing operation is called the penetration. This produces the cut band as the punch and die edges cut into the stock and begin separating the metal. The third stage is called fracture. Fracture is the rapid separation of the blank from the stock. The jagged or rough break-off is the fractured surface. This angle is the taper of the break-off. The taper of the break-off is a result of the clearance between the die and the punch. The edge of the break-off is called the break edge, or simply the break. Note that the break edge of the scrap strip faces the break edge of the blank. These edges identify the side of the blank and the scrap strip that are called the burr side. The edges of the sheared material must be inspected for indicators of incorrect shearing. The burr side and burr should be frequently examined during the production run. You can feel the burr by rubbing your thumb over the burr side. This is an example of a burr side that is normally acceptable. If the punch and die are sharp, the break edges will be sharp and clean. There will be just a slight burr on the edge. This is an example of a burr side that may be unacceptable. It has a large burr on the break edge side. The large burr will also be accompanied by a radius that is too large, a smaller taper angle, and a larger cut band. The burr is an indicator that the punch and die are dull, worn, or misaligned. This is an example of a double break on the blank edge. It is also an indicator of incorrect shearing.
A set of troubleshooting job aids is provided with this lesson. These job aids help the trainee in identifying many piece part problems and determining the appropriate action to take. There is a job aid for indicators of incorrect drawing, for die assembly problems, and for problems caused by blank material. Lesson 5 covers how to read a gauge ticket and how to gauge and measure piece part features. A wide variety of go, no-go type gauges are shown, as well as different types of gauge fixtures and measuring instruments used in press shops. Lesson 6 is the first of 3 lessons which train an operator to become a die setter. In this lesson, the trainee is shown how to use the setup controls on the press and learns the proper procedure for unclamping the die assembly for removal. This lesson continues the die setter training from Lesson 6. In the following segment from the video lesson, the trainee is being shown how to rough adjust the shut height during installation of the die assembly.
Rough adjust the shut height, you will use the length of the stroke which is given on the specification plate on the machine. You will adjust the shut height until the distance between the ram and the punch shoe is greater than the stroke length. This adjustment is performed at top dead center.